back. And it's been about 7 months since my last upload and kind of disappeared there for a bit. I haven't been posting, I haven't really been active in Discord. And I know a lot of you have been wondering what happened, or if the series is continuing, or if it's dead. And honestly, life just got busy. It's not a very exciting explanation, but I've just been working full time, doing school full time, and juggling a bunch of other projects that take priority. And on top of that, I ended up taking in a stray puppy. So that's been a bit of an adventure. So it definitely wasn't anything intentional. I didn't quit. Just had a lot going on at once. I also want to say, for those of you in the Discord, we're at around 100 people now, which is pretty awesome. I've been absent there too, and I appreciate everyone who stuck around, helped each other out, and kept things going, even while it wasn't active. It's awesome to see people helping each other out, asking questions, and we got people of very different skill levels and professions even. I'm sure there's people that are in IT or cybersecurity that are in there. Anyway, I'm back now. I've been wanting to get back into this for a while, and we're gonna be picking up right where we left off, and we're gonna start with a little introduction into peripherals. I know this is something that's been requested quite a bit. It took some time to experiment with, because as you will see, it is not super straightforward, unfortunately. When it comes to peripherals with Create or Mekanism, for example, it's there's some trial and error involved. But I'll give you some tools that you can use to get started and understand how to find these peripheral functions that you can use. Anyways, we'll start with what is a peripheral? That's the first question. At a basic level, it's just any block that the computer can interact with. So we can put a chest, we could put an energy cube from Mekanism, and what else? Let's put a comparator. Oh, put it in the back. Okay, so how do we find these blocks? Well, there's a little function we can put together to help us out. I'm going to start with create a function called get peripherals. This is what I did to find what blocks had any functionality at all. And it's going to be just a little for loop. So we're going to look for the name. We're going to use iPairs because this spits out a list. And order kind of matters here. So we're going to get the names of all of the peripherals that are connected currently. And let's end that off. We're going to print the name. And then we're going to do the type. Every peripheral has a type, which gives you a clue of what kind of commands you can do. And then we'll call this function here. And I realize I spelt that all wrong. There we go. Okay, so let's just run video 17. So we have two peripherals here. On the right, we got the advanced energy cube. And on the left, we got the Minecraft chest. It would appear that the comparator does nothing, so we can get rid of that. How do we know what functions are available to us with these two blocks? Well, that is the next step, is we need to find what's called the methods. We'll make another function here called get methods. Now, we'll do another for loop, pretty much the same as before, same exact thing. Do iPairs again. Get the names, and we're just going to go ahead and print. We're going to use the text utils, and we need to serialize it because this is going to print out a big table of stuff. Peripheral get methods. Okay, let's see what we get with this, and we'll run that. Uh-oh, hold up. Ah, I have an S in there. There we go. So we get this. We got our, this looks like it's for the energy cube. I guess we can just put in here as well, just to make things easier. Peripheral dot get type name. There we go. Now we know kind of what these are for. So we got our energy cube, and these are all of the methods that are exposed to us. Same with the chest. It is we got a much smaller list, but we can still work with this. Now, there's some caveats. There's no command to see what, like, any details about what these methods do, what kind of arguments they take, and what they return, if any. So that's why I was saying that it's a bit of trial and error involved. Looking at the energy cube, We can definitely make, a monitor that shows the energy levels with get energy and get max energy, kind of like a little visual battery. I can totally see that. But there's also a lot of other things. So seems like there's a lot of possibilities. A little example I can do is with this chest, there's a list method inside. So let's go ahead and just throw some stuff in there. All right, so we got cooked mutton, steel axe, melon slice, and tinted reverse ethereal glass pane. That's a mouthful. Just grabbed a bunch of random stuff. So let's make ourselves a little function here to get the inventory. We're going to declare a local variable. Just going to call it inv. And we're going to use peripheral.wrap just because we already know what this peripheral is called. If we run this program again, we can see it's just Minecraft chest. So I'm going to put Minecraft chest in here. Now we're going to do a for loop, and we're going to get the slot and the item. And we're going to do pairs. Do inv list. So the list command, or list method rather, it outputs a table. So let's say I get rid of this and I just do inv.list. We can look and see what we get from this. We're gonna go ahead and comment out this get methods because it adds a lot of gibberish to the screen. Yep. So here we go. It did not work. We're just gonna go ahead and print the slot, the item, the name of the item, and the item count. Oops. Uh-oh. You know what? We might need to do a find. There we go. My mistake. So I guess Minecraft chest is not good enough. It wasn't the exact peripheral name. So when in doubt, you can always use peripheral.find. It is a much more beginner-friendly function to use. Anyway, so we can see that in slot 1, we got our cooked mutton 64. Slot 2, slot 3, slot 4. We can see what these are named, which is helpful. Yep. So here we go. So I guess we got that error because I was not wrapping the correctly named peripheral. But now that we have the correctly named one in use, I went ahead and just tried to print inventory.list. And yep, as you can see, it just spits out some table. So that is a clue that you're working with a table. Therefore, you're going to have to use a for loop to pull data out. So we'll put that back how it was. We can list our inventory, which is great. Now, I guess we'll go into another thing here. You can see the computer only has a limited number of sides. What happens if we use up every single side, right? Then what? I don't know if you're aware or if you've ever messed around with the wired modems. This is a way that we can extend the amount of interfaces that our computer has. So we just use the wired modem and the networking cable. Right click to turn it on. Computer 2 is the name of this. And you can extend this out. So let's just say we have a chest here and a chest here. Put the modem to connect to this block, and then another modem to connect to that block. So basically, each of these modems now gives you like 6 more sides. Well, 5, because you have a cable. So you get 5 more sides to work with. And it's pretty much endless as far as how much you want to add to this. Of course, you can use wireless modems. That is always an option. But this is, I'm just going to go through modems for now. Just the wired modems. So let's delete this chest and put this stuff in here. So we got chest 2 and chest 3. Chest 3 has all the stuff in it. I'm gonna get rid of all these. All right, so let's run this command. We can now see, now we have a modem in the back. We got chest 3 and chest 2 popping up here, and we can see all these items that are in chest 3 currently. Let's clear this and run this again. All right, I want you to take note. There's 12 slots being used. Let's see what happens if I take an item out, put it in this chest, and then rerun it. As you can see, now slot 1 is missing, and it does not show the inventory of the other chest. So this is why I earlier was using peripheral.wrap, because now we have an actual name to these. So we can do chest underscore 2, clear this and run it. And we can see our cooked mutton in slot 1 by wrapping chest 2 in particular. So what if we want to list everything? What if we had like a whole network of chests? We would use like some sort of loop to go through all of these different chests. I guess for the simplicity's sake, I'm just gonna like hard code them in. So I'm gonna make another function. We'll just call move items. Say we want to move an item from one chest to another. And I'm going to declare 2 local variables. I'm going to do chest 2, chest 3, because that is what we're working with. Now we're going to do peripheral.wrap Minecraft chest 2. We're just going to copy paste this. There we go. Minecraft chest 3. So now we got these in there. You know what? Let's just go ahead and list them. This is chest 2, chest 3. Maybe what we should do is run the inventory function and pass these objects to this function. So I'm just going to put object as the variable, and we're going to do inventory, and I'm just going to spell it out again. This isn't like efficient code by any means. Now I am going to replace this because now what we're doing is we're running this function. We're passing these peripherals that we want to do it with. So now we don't need to actually wrap it to anything like the specific one. We want to wrap it to the object that's being passed through. So we're just going to put object here. So now if we run, actually we do need to actually call move items. We run this program, we should see stuff in both chests now. We got chest 2 and chest 3. That's pretty nice. So how do we actually move the items? Before we get into that, I'm going to do a little quality of life thing for you if you actually like use these functions I'm putting together here. I made this ComputerCraft terminal 3 times bigger. It's a lot bigger than normal. But even so, if you have a bunch of items or a bunch of peripherals connected, you're gonna not be able to see everything, which kind of sucks. So the way around that is to just output it into a file. And what I did is I just did a little handler, made a file called methods.txt, open it in write mode, and then instead of just printing it, I just did a f.write. And now all of the methods available will just go into this methods.txt file, which is very nice. So we can clear and run this again. And now we do, oh, well, it would help if I actually called this function, huh? Run it again. We do a little ls, we can see that we have a methods.txt here. And if we edit, now we can actually see everything and kind of go through it, which is very helpful, I think. Anyway, with chest, we have pull items and push items. I guess it doesn't really matter which one you use. They do kind of the same thing in this context, moving an item from one chest to another. But in my experimenting, I just went with push. So I am essentially pushing an item from chest 3 to chest 2. Now in here, underneath the inventory calls, chest 3. Now, anytime we actually use these methods that we see in this text file, like push items, it's going to be the peripheral name, the handler here that we declared, dot, and then the method name. So in this case, we're going to do push items, and then we need to put in the what storage we are pushing to. We're going to do peripheral dot get name chest 2, and then we can do a comma, and this is going to be an integer for which slot. Now, I don't remember. Let's run this again real quick. Okay, so in chest 3, let's say we want to move some of these melon slices. So in slot 4, we'll go ahead and run it. Okay, so now if we look in this chest, we have all our melon in there. It's no longer in this one. If we run it again, it'll look different because now there's mutton and melon in chest 2. Now you may be wondering, what happens if I want to just move like only one melon? Well, since it's in chest 2, we're going to do the originating chest and then do chest 3 as the destination. We can actually add another argument here, another integer for how many we want to move. So let's say we'll just move one melon. Run this a couple of times. Oh, well, you know why that didn't work? Let's say I'll give you a couple seconds to figure this out. Why did this not work? Well, it is because it's no longer in slot 4. It is in slot 2. So let's rerun this again. Yep, so now we have 62 melons in there, and then 60 or 2 melons in this one. I honestly had no idea that you can do this with vanilla Minecraft chests, personally. Peripherals is not something I've really messed with too much. Let's do one more quick example. Let's do this energy cube and get how much energy we have in here. Let's go in here and make ourselves a new function. Let's do get energy. Now we need to do the peripheral.find. So I'm going to do a local cube peripheral.find energy. Actually, I don't even remember what it's called. It is advanced energy cube. It is case sensitive. Just keep that in mind. So now we have the advanced energy cube stored in cube. So let's look at what the methods are. So we have get energy. So if I had to guess, what this would do is it would just output an integer. So let's just try and print cube.getEnergy. Let's see what happens. Comment these out because we don't need them. And get energy. Let's run it. So we get this big number. This is a 6.4, and this is giving me a 1.6 and a bunch of zeros. So it's a little odd. I'm not too sure what this number really means, to be honest. But let's see what the maximum energy is. So I think it's print cube.getMaxEnergy. I'm just guessing. Oh, is that? Well, I guess it is completely full, so that would make sense that they are exactly the same. Let's get rid of this and get an empty one. There we go. Let's run it again. Cool. So it's now 0 out of, what is that? Is that 16 million? We can get ourselves a little solar panel. Slowly fill it up. There we go. So now we should see that number changing. We can do while true do, let it do that. We can let it sleep for half a second, something basic. You know what? We can definitely format this to be much prettier looking. Concatenate this. Do a little pipe. Concatenate cube.getMaxEnergy. That should look better, I think. Yeah. You know, it's another example, kind of what you can do. You can definitely make it look a lot prettier with some color and some graphics. But yeah, that's, we can pull how much energy we're getting from this. Yes, I'm going to call it here. It's just a little introduction into peripherals, how to find which peripherals you can use or at least interact with through ComputerCraft. And then we went over how to find the actual methods that you can use. You just have to experiment with it. So naturally, this is a little bit more intermediate territory here because you're gonna have to kind of do your own digging. But I'm willing to answer questions, and bear in mind that I am also figuring it out as I go. Like, I've not messed with these peripherals. I do not know what like increment output color really does, for example. So, we're all learning together. If you find anything cool, post about it in the Discord. I'm sure people would be very interested to know. Next time, I'm going to experiment with this a little more. We'll go into how to maybe do some Mekanism automation or how to use this with the create mod in the next video. Anyway, I hope you all enjoyed, and I'll see you again very, very soon. Bye-bye.